Okay, since we didn't get to do in-class programming exercises today, I'm going to work through some of them myself and record them for you. So the first one is what we started but didn't get a chance to finish, and that is define a class summable list that inherits from lists and adds a method to sum up the values in that list. Okay, so if we just start off with defining the class, it's going to be summable list, and it's going to inherit from list. In this case, let's just start with this. So this is just going to be identical to a list because we didn't add any functionality to it. We can do a.append 5, print a, print a. It's behaving just like a list. So that's kind of our first test that we got something working right. Okay, so let's write a docstring for this. Extends a list to add a method sum that sums the numeric values in a list. Okay, so let's add this define sum. It's going to take as an argument itself. And now let's do this, and let's print a.sum. Okay, so it returns none, which is what this function does. It doesn't. We have pass, and then it will return implicitly return a none. Okay, so now we need to do the summation of the integer parts. So the question now is, how do we get the individual elements of a list? So let's define a list, and having defined it, let's explore its properties and see if we can find a method that would iterate over the individual elements of the list. So nothing there. Okay, let's look at the magic methods. Okay, there's this iter method. So let's see what it does. Okay, iterator, a list of objects, so it creates an iterator. And so that means we should be able to take this and iterate over each element in the list. So let's see if we do that. So if we do like for I in b iter, we should be able to print I, and we're getting the individual elements of the list that way. So we can use that in our summation method now. So let's just do this before we do the summation. Let's just have the sum be a print for I in self iter print I. Make sure that this seems to work. Okay, now when we call sum, we are in fact printing out each of the elements in the list. Okay, so we know that the iter is properly accessing it, and now we want to do a summation if it's a numeric type. So kind of separate from this, I did some searching on the web and found that there is a module called numbers that's been defined in Python since version 2.6. And so it has a base class number that we can use to check to see if a particular variable is a numeric variable. So we're going to use this is instance of, like we talked about in class. Bring this back over here. Get our class of the next one. So we'd say if is instance, our variable is I, and we need to do numbers.number. Fix that. So if this is an instance of a number, then we're going to take our variable s, and we are going to do s plus equals I, and then we can return s. Okay, so now let's see how that works. Okay, now when we do the summation, we're getting a 15. So we can make a more complex thing. So that's a sum. If we add a floating point number, we should be getting a floating point in return, and we can even be getting a complex number, and we get the summation there. So that is our first example of extending a list and adding a method called sum.